Okay, folks, so we're going to work a few examples really quickly now in order to look at more situations where we end up with free variables, etc. So let's go ahead and give the augmented matrix to this problem. In our first step, we go ahead and divide this row by 5. I'm not going to annotate it any longer. We get 1, 1, 2, 2, 2, 5. Now I'm going to go ahead and multiply this pivot row right here by -1 and combine it to this row. So we get 1, 1, 2. This will give me 0, 0. I'm multiplying by -2, so that's -4, added to 5, which gives me 1. Let's look at the corresponding system of equations that we now have. This equation right here says 0x plus 0y is equal to 1, which just says 0 is equal to 1. Well, this statement is false. So in doing this matrix row reduction procedure, we ended up with an equation that was incorrect. It was false. And so what do we conclude? We conclude that there is no solution. Graphically, what are we talking about? Well, if you think of each of these equations as represents a line in tube space, normally when you're asking for a solution, you're looking for at which points does this line intersect. And in this case, we have two parallel lines that never intersect. And so there is no solution when we go to solve this. So I've just shown you how to encounter or how to deal with a situation where you have no solution, and that is where you have an equation that says 0 is equal to 1, or 0 is equal to any other number other than 0. Okay. Let's go ahead and look at number 3 here. So this is a similar problem as far as setup is concerned. We get 5, 5, 10, 2, 2, 4. We go through to do the matrix row operations. We divide the first row by the coefficient of this first pivot position, 5, so we end up with 1, 1, 2, 2, 2, 4. Now we want a 0 in this pivot position, so what we do is we go ahead and we multiply our pivot row by -2 and add down, and when we do so we end up with 0, 0, 0. So in this case, this gives us the two equations that 0 is equal to 0, that's that second one, which isn't very helpful, and x plus y is equal to 2, or that x is equal to 2 minus y. So that's the second one, and there's the first one. There's the second equation, there's the first one. So as we saw this same situation in an earlier example. It was quite a bit longer, but what we end up with is we started off with we've got an equation with two variables, and only one of those gave us a pivot column. Okay, so how would we represent the solution? Well, if we represented the solution as an ordered pair, notice that we can choose whichever value we want for y. There is no corresponding equation for y, so let's let y equal, say, r, like we did in the previous video. And so then we would represent our solution as 2 minus r, comma r. So, for example, you wouldn't do this, but let me just show you. If r were 3, then our solution would be 2 minus 3, comma 3, or -1, comma 3. That's an ordered pair that solves this system of equations. And if we picked any other value for r, we could find another corresponding ordered pair. So in this case, we'd say that we have infinitely many solutions. Okay. Notice we have two variables. One of them yields a pivot column, so we have one remaining column that yields a free variable. So we'd say we'd have infinitely many solutions with one free variable. Okay, folks, sometimes I'll say free, sometimes I'll say arbitrary. You can say it either way. Okay? The last thing I want to do is talk about just how else can we represent this. We saw that in the previous example. How else could we represent the solution? Well, we're looking for a solution that looks like x, y, right, that vector there. And we said, well, x would be 2 minus the choice of r, and y would be r. We could break this down as x, y, and I'm going to go ahead and break this down into a sum of two vectors. The first one only has coefficients in it, so 2, 0, and the second one has is a vector being multiplied to our choice of the free variable r. So we'd have -1, 1. Notice that if you were to simplify this through vector addition, you'd have 0 plus r times 1, 0 plus r, that would give you the value for y, yep, that's right, and 2 plus r times negative 1, or 2 minus r, yep, that's what we had for x. So I want you to practice writing your solutions this way. This will become more important as the course goes along. Okay, so let's look at two more examples of this. Let's look at number 4 here. If I put this into its augmented form, we'd have 1, 0, 0, 1, 0, 0, 1, 1, 1, 3, and 2, 0, 1, 4, 1. Okay, we want to go ahead and put this into RREF form. So notice we already have, this will be our first pivot column. We want zeros below it. So the first row we'll just copy over. The second row is good to go. It's already got a 0 in that position. And then I'm going to get a 0 here by multiplying the pivot row by -2 and combining it down. So I'm going to multiply this row by -2. That'll give me a 0 here, 0 here, 0 here. That's -2 multiplied to 1. It's -2 added to 4, which is 2. And this would give us a, we multiply this row by 0, this 0 by -2, and add down, we get 1. So notice, okay, we've got our first pivot position, we've got zeros below it, then we step 1 to the right and look down, and sure enough, down in this column we've got a non-zero entry, but it's already a pivot 1, it already has zeros below it, so that's looking good. Then I would try to get a pivot in this position, but notice this entry is 0 and I have no other rows, so this is not going to have a corresponding pivot column. So then I scoot over 1 and I've got a non-zero entry here. This becomes our next option for a pivot position, and sure enough I can get a 1 there. So we go ahead and do so. By dividing this row by 1, and we get 1/2. Okay, so let's go ahead and talk about how we would represent this solution. Okay. So let's see here. This corresponds to W is equal to 1/2. Notice that there is no pivot column for Z, so we just say Z equals, and we pick a letter, so let's pick R. Okay, so Z is a free variable because it doesn't have a corresponding pivot column. Again, to be a pivot column, you've got to have an entry of 1 and zeros to the left of that. Well, I don't have. Notice that there is no corresponding pivot column for the variable Z. Okay, there is one for Y, there is one for X, and there is one for W, but there isn't one for Z. So that makes Z a free variable. Y is equal to, this is Y, this is Z, this is W, so Y is equal to 3 minus W minus Z. But we said that W is 1/2, and we said that Z is R, so we could write that as, let's see, that would be 6/2 or 5/2 minus R. And then finally we have that X is equal to, so that's 0, and we would subtract over the W position, so we'd have, by the way, folks, I didn't say this. If you use a W, for some reason, we usually put it after Z. And so for our X position, we would just have, we would have negative W. But we already said that W is 1/2, so we get that X is equal to negative 1/2. Okay? So as a ordered quadruplet, we would write our solution as, we'd write it as negative 1/2, comma, 5/2 minus R, comma, R, comma, positive 1/2. And that's a way of representing the solution. If we wanted to put it in that vector form, we'd have X, Y, Z, W, and we have that's equal to negative 1/2, 5/2, 0, 1/2, plus R times 0, negative 1, 1, 0. Okay? Take a few minutes to see why this information is the same as this information here. Notice X would equal negative 1/2. Y would equal 5/2 minus R. Z would equal 1, etc.